In the summer of 1851, in the dense, folded mountains of western Massachusetts, a crew of men lowered a 100-ton machine into a cut of raw rock on the face of Hoosac Mountain. It was called Wilson's patented stone-cutting machine, a wheeled, tooth-rimmed leviathan of cast iron that was supposed to grind its way through 4 3/4 miles of solid granite. Engineers had promised the state legislature that this contrivance would bore the tunnel in 3 years. It advanced 10 feet into the mountain, then it seized, jammed against the gnarled Berkshire's gneiss, and died. They hauled it out in pieces, and what remained was the mountain, and the men who would have to go through it by hand. The problem was simple and brutal. The Hoosac Range stood directly across the only viable path for a railroad connecting the factories of eastern Massachusetts to the industrial cities of the Hudson Valley and the Great Lakes. Trains could climb the grades of the Berkshires in good weather, but the curves were too sharp, the inclines too steep for heavy freight, and in winter the passes became impassable for weeks at a time. The state of Massachusetts and the Troy and Greenfield Railroad concluded there was one solution: a tunnel, straight through the spine of the mountain, 25,081 feet from portal to portal, the longest bore ever attempted on the continent. No one had ever driven a tunnel of this length through hard rock in North America. No one had any certainty it could be done at all. The estimate was $2 million and 3 years. It would take 24 years, $21 million, and something close to 200 lives. The men who worked the headings called it the Bloody Pit. They called it that long before it was finished, and they kept calling it until the day the last charge was fired, because the name was simply a description of what they saw every morning when they descended into the dark. How do you dig nearly 5 miles of tunnel through solid granite with no machines? That is the question that hangs over the entire history of this project, and for the first 15 years the answer was, you do it the way men have always done it. You swing a sledgehammer, you hold a chisel. You drill a hole into the rock face by hand, turning the bit a quarter rotation after every blow so the cutting edge strikes fresh stone each time. One man holds the drill steel and turns it. Another man, or 2 men, working in tandem, swings a long-handled sledge, driving the steel deeper, inch by inch, into the hardest stone in New England. A good crew could drill maybe 4 feet of hole in a 12-hour shift, and that was on a good day, in good rock, with fresh steel. Then you packed the hole with black powder, tamped it with clay, ran a fuse, and cleared the heading. The blast went. The air filled with smoke and dust and the bitter reek of sulfur, and when the smoke cleared, the muckers went in with wheelbarrows and shovels and hauled out the broken rock, carting it out along timber tracks in the dark, and the drillers went back to the face and started again. Drill, charge, blast, muck out, drill again. 5 days a week, 6 days a week, sometimes 7, for years. The rock was not uniform. On the eastern end, the mountain was dense, fine-grained gneiss and mica schist, hard but predictable, the kind of stone that broke clean when the charges were placed right. On the western end, the geology turned vicious. Workers encountered what they called porridge stone, a collapsing nightmare of quicksand, wet clay, and disintegrating rock that crumbled as soon as it was exposed, flooding the heading with water and debris. Men shoveled muck standing in water up to their knees. Timbers snapped under the pressure of the mountain. The walls moved. At the west portal, engineers eventually had to build a drainage system and a cement wall 10 feet thick and 30 feet deep, just to hold the mouth of the tunnel open. Later, after enough men had been killed by falling rock, the state authorized more than 5,600 linear feet of brick arching, essentially lining a third of the entire tunnel in masonry, to keep the mountain from closing back over the men inside it. The central shaft was its own world of danger. To accelerate the work and provide ventilation, engineers sank a vertical shaft 1,028 feet straight down from the top of the mountain to the tunnel grade below. It was an exhaust shaft, a breathing hole for the completed tunnel, but during construction it served as a third working face. Men drilled and blasted downward from the bottom of the shaft, while other crews worked inward from the east and west portals. The shaft was a cylinder of black air. Men were lowered in buckets and on wooden platforms hoisted by steam engines at the surface. Water seeped in constantly. Pumps ran day and night. The walls wept, and everything that fell, tools, stone, timbers, sparks, fire, fell down into the place where men were working. On the evening of October 17, 1867, 13 men were working at the bottom of the central shaft, 538 feet below the surface. Above them, in the hoist building at the shaft's mouth, a candle flame touched invisible fumes that had been leaking from a naphtha lamp used for illumination. The explosion was instantaneous. It tore through the hoist structure, set the wooden staging ablaze, and sent the burning hoist platform, along with shattered iron and flaming debris, crashing down the full depth of the shaft. The pumps were destroyed in the collapse. Water began rising from below. The 13 men below, James Burnett, James Kavanagh, Peter Collins, Thomas Collins, Patrick Connolly, Thomas Cook, John Curran, James Fitzgerald, Edwin Haskins, James McCormick, Joseph Messier, Thomas Mulcair, Michael Whalen, were trapped. Rescuers reached the surface of the shaft and found the fumes too thick to descend. They could hear nothing from below. It took nearly a year to recover the bodies. When they were finally reached, the evidence told a story. The men had survived the initial fall. They had built a raft from floating timber to keep themselves above the rising water. They had lasted long enough to try. Then the gases had taken them. Those 13 names are recorded. Most of the dead of the Hoosac Tunnel are not. The project's labor force was drawn heavily from Irish immigrants fleeing famine and poverty, from Cornish miners who had worked the tin pits of Cornwall, from local farmhands and quarrymen, and anyone willing to take the wages. They came because the work paid, when it paid, and because there was nothing else. They lived in boarding houses and shanty camps near the portals. Whole families crowded into wooden structures that shook when the blasts went off inside the mountain. Their children played near the works. In September of 1874, a 14-year-old boy named Orrin Wilson, the son of a tunnel worker, was found near the shaft with his skull crushed by an elevator. A friend had been with him. The friend ran and never came forward. Orrin Wilson is one of the last names on the death list. The list is not complete. Many entries read only unknown, or an Englishman, or brother of. The record is full of gaps where a name should be, because no one wrote it down, or because the body was never found, or because no one asked. The workers had a song. They sang it while they swung the sledges and turned the drills, the way sailors sang chanties to time the hauling of rope. Drill ye tarriers, drill, for it's work all day, for the sugar in your tay, down beside the railway, and drill ye tarriers, drill, and blast and fire. The word tarrier, some say it came from terrier, meaning a dog that digs, or from the Irish vernacular for a delay, or simply from the act of tearing into rock, became the name the men gave themselves. The song was cheerful, the work was not. Families waited outside the portals when blasts went wrong, crying in the open air, waiting for a body to be brought out, or for word that someone was not coming back. The newspaper columns of the North Adams area during those decades are a litany of the dead, killed by a falling rock, killed by an explosion, killed by a fall, killed by drawing a charge, meaning a man who was trying to remove a powder charge that had failed to detonate, and it detonated when he touched it. Drawing a charge was one of the most dangerous tasks on the tunnel. A man would go to the face, find the hole that had not fired, and begin to dig out the tamping and the powder with a small tool. Sometimes the powder was merely slow, sometimes the fuse had smoldered. The charge went off in his hands. The names attached to these deaths are ordinary names. John Fennell, Daniel Bradley, Fred Trombley, Patrick Shea, John Kennedy, Michael Harrington, Dennis McFadden, men with families, with hands that could swing a sledge and eyes that could see a drill line in lamplight, reduced to a line in a newspaper and a hole in the ground. If you are finding these stories worth hearing, take a moment to subscribe. The work of remembering these men depends on people who care enough to listen. The project nearly collapsed a dozen times. After the initial estimate of $2 million, the cost climbed relentlessly. $5 million, $10 million, $14 million, until the final figure reached $21 million, more than 10 times the original projection. The Commonwealth of Massachusetts took over the tunnel from the private railroad company in 1862, turning it into a public works project funded by state bonds and legislative appropriations that were debated and fought over every session. Politicians called it a boondoggle. Newspapers called it a fraud. The legislature commissioned investigations. Work stopped and started. In 1857, the railroad ran out of money and ordered the chief engineer to discharge every laborer and suspend all operations. The mountain sat silent. The headings stood open to the weather, half filled with water, the timber rotting. Then a new appropriation was passed, and the men went back in. A succession of engineers tried to finish the job. A.F. Edwards was first, then Edward Wellman Serrell, then Herman Haupt, a brilliant organizer who would later run the Union Army's railroad system during the Civil War, then Thomas Doane, then the Canadian brothers Walter and Francis Shanley, and finally Bernard N. Farren, who guided the tunnel to its completion. Each man brought a different strategy. Haupt advocated for the central shaft. Doane pushed for mechanical drilling. The Shanleys reorganized the contract structure and disciplined the finances. What none of them could change was the fundamental fact that the mountain would yield only to force applied one hole at a time, one blast at a time, 1 inch at a time. The technology did eventually change, and it changed because of this tunnel. In 1866, after 15 years of hand drilling and after a procession of failed machines, the 100-ton excavator that stalled at 10 feet, a 40-ton blade-headed borer that froze in the rock, a steam-powered percussion drill destroyed in a foundry fire before it ever reached the site, a machine finally worked. It was the Burley drill, a 372-pound pneumatic drilling machine designed by Charles Burley and powered by compressed air. Thomas Doane had built a crib dam on the Deerfield River, channeled water through a canal to a compressor building near the east portal, and let the water drop 30 feet to drive the air compressors. The compressed air ran through pipes into the tunnel and into the drills. The Burleys were mounted on a track-mounted carriage that workers could roll up to the face, position, and drill multiple holes simultaneously. The machine could drill 116 feet of hole per month, more than double the rate of hand drilling at roughly half the cost per inch. Eastern progress jumped to 160 feet per month. Western progress reached 120. The tunnel that had crawled for 15 years began to move. The other innovation was explosive. For the first decade and a half, men packed black powder into hand-drilled holes, the same substance that had been used in mining since the Middle Ages, unpredictable in hard rock, prone to misfires, generating toxic smoke that lingered in unventilated headings for hours. In 1867, a chemist named George Mowbray arrived at the western portal with a new substance, a highly purified form of nitroglycerin he called trinitroglycerin. He built a manufacturing plant near the tunnel and began producing the explosive on site. The Hoosac Tunnel became the first large-scale commercial use of nitroglycerin in the United States and the first use of electric blasting caps, wires running a fulminate core that could detonate the charge from a safe distance, replacing the unreliable fuses that had killed so many men when they burned too fast or too slow. Workers learned that nitroglycerin was stable when frozen, so it was shipped and stored in a frozen state and thawed before use. It was vastly more powerful than black powder. It shattered the gneiss in ways powder never had, and it was, in its own way, equally dangerous, sensitive to shock, to heat, to a careless hand. Men died from nitroglycerin too. The names are on the list. On Thanksgiving Day, 1874, The last 16 feet of rock were blasted through. The eastern and western headings, two tubes driven through a mountain from opposite sides, guided by surveying instruments that had to maintain alignment over miles of underground darkness, met. They met within inches of their intended line, a feat of 19th-century engineering precision that is difficult to overstate. On February 9, 1875, the first train passed through the Hoosac Tunnel. The bore was 25,081 feet long. It was the second longest tunnel in the world at the time of its completion, and the longest in North America for more than 40 years, until the Granite Tunnel surpassed it in 1916. The American Society of Civil Engineers designated it a historic civil engineering landmark. Lewis Cuyler of the Hoosac Tunnel Museum Society called it the fountainhead of modern tunnel technology. He was right. The compressed air drilling, the use of nitroglycerin, the electric blasting caps, the deep vertical shaft as a working face, these were not refinements of existing practice. They were inventions born of necessity, tested in the granite of the Berkshires, and then carried to every major tunneling project that followed. What changed was the economy of New England. The tunnel opened a direct, all-weather freight route between the mills of Massachusetts and the markets of the West. Trains no longer had to climb the mountain passes. Coal, grain, manufactured goods and passengers moved through the Hoosac in quantities that the old rail lines could never have carried. The communities of the Deerfield Valley and the northern Berkshires grew around the rail traffic. The tunnel became a spine of commerce, and it remained one. It still is. The Hoosac Tunnel is not a ruin. It is not a museum piece. It is an active freight corridor, still carrying trains through the mountain, still the longest active transportation tunnel east of the Rocky Mountains. Amtrak and Pan Am Railways and Guilford Transportation and their predecessors have run trains through it for a century and a half. The brick arching that was laid to protect the workers still holds the roof above the rails. The bore that men drilled by hand for 15 years still carries the weight of commerce that a modern economy depends on, and most of the people who ride over it or consume the goods that pass through it have never heard of it. And the men? The record says that approximately 195 workers were killed or seriously injured during the construction of the Hoosac Tunnel, with about 135 deaths verified by name. The real number is almost certainly higher. Men were blown to pieces by nitroglycerin, and there was nothing left to count. Men were buried under rock falls that were never fully excavated. Men died of disease in the camps, of infections from wounds, of exposure in the winter mountain. Some bodies were never recovered. The 13 men in the central shaft lay at the bottom of the shaft for nearly a year before they were brought up. Their families had already buried empty coffins by then, or nothing at all. There is no grand monument at the portals listing the names of the dead. There is no wall of engraving. The names exist in newspaper archives, in railroad company records, in the patient research of local historians who have spent decades reconstructing the list, one name at a time, and even that list is full of holes where a name should be and is not. If there is a name you recognize here, or a story from your own family that connects to this mountain, leave it in the comments. The record is incomplete, it always will be, but every name added is one less that disappears.